Okay, so today we're going to learn about area. Most of this should be a review, but just remember that area means how much space is filled inside a figure. And you may use your formula sheet on this, so you probably want to get that out to use as we go through this lesson. And you may also use the formula sheet on your homework, on the test, and on the SOL. So the first shape we're going to do is area of a triangle. Area of a triangle is 1/2 base times height. And the key thing is you have to remember is height must form a right angle. And so the height is always perpendicular to the base. Okay, and it must form a right angle. That's how you know it's called the height or the altitude. And it's going to be perpendicular to the side. So on this first one, it says label the height and base of the following triangle. So the first one's already done. If it's a right triangle, the height and base are just the two sides or the two legs. For a non-right triangle, the height, if it's acute, the height is going to be here in the middle, and then that's perpendicular to this side, which is the base. And just be careful, base does not mean bottom, it means what side the height is perpendicular to. And then the hardest one is an acute or an obtuse triangle. You're going to have to draw in the height. So we need a right angle. So the only way to draw the height or the altitude is here. So this is the height, and then the base, though, is still the base of the triangle. So you always need the base to be on a side of the triangle. So these three examples, we're going to find the area of the following triangle. Again, we have the formula. If they don't give it to you on the page, then you look on your formula sheet. So we need 1/2 base times height. This is a right triangle, so 60 is my base, and then this missing side is my height. So I need to find that. So they gave me this angle is 30 degrees, and so we have this opposite side and adjacent, and remember O and A is tan. So I'm going to do tan of 30 is equal to opposite, which is H, over adjacent, which is 60. And then we can put this over 1, over 1, and then cross multiply. So if we cross multiply, we get 60 tan 30. And then you have to use your calculator to figure out what that was. And if you do this, and if we round to the nearest tenth, then the height is 34.6. And then for area, now we have all the parts, so I'm going to do 1/2, the base, which is 60, the height, which is 34.6. And then you can plug this in your calculator, and you will get 1038. So our second example, we want to find the area of this triangle. So again, it's always good to first identify the height. So this is my height because it makes a right angle, and then this will be my base. And we'll just say that the base, this is only half of it, so this is also 6 then, so then the base is going to be 12. So to find the area, we would do 1/2 the base, which is 12, times the height, which is 5. Again, you can put this in your calculator, or if you multiply it in your head, just remember you do 1/2 of the first number, which is 6, and then multiply that just by 5. So you get the area to be 30. So the third example, this is our obtuse triangle. On the quiz or test, it will say find the area of the solid triangle, so I want this bold one. So they don't tell me the height. This is the height because this is the altitude. It would make a right angle. So I have to use, in this case, Pythagorean theorem to find it because I know two sides and I'm trying to find the third. So I would do a squared plus b squared equals c squared. And then you can solve it. So we get h is 3. And then when we do the area formula, we do 1/2 the base of the triangle we're trying to find, which is the solid. So that's going to be 6, and then the height of 3. And then 1/2 of 6 is 3, and then 3 times 3 is 9. So our second shape is a parallelogram. Now, a rectangle, a square, and a parallelogram are all different types of parallelograms. So for all of these shapes, it's base times height. For a square, a lot of times we say the area is s squared because the sides are equal, and so the side times the side gives me side squared. So for this first one, we have a rectangle, base times height. You can also say length times width. It doesn't matter. So this one, the base is 4, the height is 10. So the area is 4 times 10, which is 40. For the second one, it says area of a square. Again, we said that's s squared. Find the expression for the area given that each side is x plus 2. So that means the area is equal to x plus 2 times x plus 2, or you could say x plus 2 squared. And if we want to multiply that out, we have to FOIL or distribute. So we do first, so that's x times x, which is x squared. Then last, which is 2x. Then inner, which is here, which is also 2x. And then, outer before, and then last, which is 4. So we did again, first, outer, which is the 2x, inner, and then last, which is 2 times 2. And so then the area expression is x squared plus 4x plus 4. And then this one, we have a parallelogram, base times height. For a parallelogram, the height is always going to be either, it has to form a right angle. So it's either going to be inside the shape, or sometimes they put the height out here, just like the obtuse triangle, but these are the same length. So to find this height, they didn't give it to me. So I need area, which is base times height. And if we look at the height, either up here or down here, it's perpendicular to this side length or this side length, which is also 15 because opposite sides are equal. So we know the base is 15, but we don't have the height. So we have this angle, 34, and opposite angles are equal. So this is also 34. And so now we have an angle and a side of a right triangle. So we're going to use trig to find the height. So h is my opposite. 10 is my hypotenuse, so I'm going to use sine. So I'm going to do sine of the angle is equal to the height over 10. Put this over 1 and cross multiply. Okay, and if we do that, we get to the nearest tenth, the height is 5.6. And then for the area, we would plug that in for 5.6, and then 15 times 5.6, the area would be 83.9. So the harder problems are where you actually have to find the height, and the options are either using trig or Pythagorean theorem. You use trig when you have an angle and a side, and you use Pythagorean theorem when you have two sides and you're trying to find the third. So then this says, don't let some questions fool you. So what is the base, what is the height, and the area? So you always first want to identify the height. So remember, a height has to make a right angle. So this 12 would make a right angle. So the height is 12. And then the base is the side that it's perpendicular to. So 12 is perpendicular to this bottom side or the top side, which are 20. So the base is 20. And then the area is 20 times 12, which gives us 160. Now, other types of questions, they're going to ask us to work backwards. And how we know that is that they give us the area and they're trying to tell us to find another dimension, like the base or the height. So this says the area of a parallelogram is 200 square feet. The base is 20 feet. What is the height of the parallelogram? So units don't really matter. Just squared means it's area. And if it's just feet or meters, that means it's a side length. And so area, again, of a parallelogram is base times height. You always first want to write the formula, and then we plug in what we know and solve for what we don't. So we know the area is 200, so I'm going to plug 200 in for A. We know the base is 20, so I'm going to plug that in for B. And then I'm trying to find the height, so I'm going to leave it as H. And then we solve the equation. So I divide both sides by 20, and then we get the height to be 10. And some of you could probably do that in your head. And the units would just be feet because it's a side length. The next shape is a trapezoid. So remember, a trapezoid has one side, one pair of parallel sides, and then the other sides are not parallel. And this is the formula we use for a trapezoid. The height is the distance between the bases. And then just like we learned last time, B1 and B2 are the parallel sides, the length of the parallel sides. So this shows you a picture. So B1, it doesn't matter which one's B1 or B2, but this is B1 in this picture. B2 is the other parallel side, and then the height is the distance between the two bases. If it's not isosceles like this, these are my parallel sides, so those are my bases. The height is a side because that's how far they are apart. And again, it has to make a right angle. So this first one says find the area of the trapezoid, and they luckily gave me everything I needed. So 5 is the distance between the two bases, so that's my height. And then the length of the two parallel sides are 10 and 6. And so then I just plug it into my formula. 1/2 the height, which is 5, and then we add the two bases. And then just make sure you do order of operations. So we do parentheses first, and then we multiply everything out. So we have 1/2 5 times 16, and that should give you 40 for the area. The second one, again, is a trapezoid, two parallel sides, two non-parallel sides. And so we need to figure out what we have. So we need to plug it into the formula 1/2 h b1 plus b2. So the height is the distance, and they didn't give me that yet, so we're going to have to find it. And then my bases are 10 and 19 because those are the lengths of the parallel sides. So we have to figure out, how do we find this height? So again, we have a right triangle. And if we look at this, we know that 10 is also this length, because if we split it into a triangle, then we have a rectangle, which means this piece has to be 9, because 19 minus 10 gives me 9. And now I have two sides of a triangle, and I want to find the third, so we would use Pythagorean theorem. So I would do a squared plus b squared equals c squared. 15 is my c because it's across from the 90. And then we would solve it. So we get h to be 12, and now we're going to plug it into our formula. So we have 1/2, the area is 1/2, the height, which is 12, and then my two bases, which are 19 and 10. You still need to use the entire length for the bases. And then we're going to multiply this out. And if you multiply that out for the area, you should get 174. So a rhombus we did before. A rhombus is also a parallelogram. So if they give me the base and the height, we can use 1/2 base times height. Or not, sorry, just base times height, not 1/2 base times height, just base times height. But if they don't and they give me the diagonal length, it's 1/2 d1 times d2. d1 is one of the diagonals, and d2 is the other diagonal. And then just remember from last unit, the diagonals are bisected, so I showed by the markings what is equal. So on this one, I have 5, 3, so we know this is 3 because these pieces are equal. And we need to find the other diagonal. A rhombus, the angle is 90, so I'm going to call this x, and then again use Pythagorean theorem. So a squared plus b squared equals c squared. If you solve this, you should get x to be 4. So x equals 4. So that means this part is 4, the other part is 4, and then the area is 1/2. Diagonal 1, so if I say this is my diagonal 1, it's 3 plus 3, which is 6, and then diagonal 2, which is 4 plus 4, which is 8. And then we can multiply that out, so 1/2 of 6 is 3, and then 3 times 8 is 24. This is going to be the same idea. I have a rhombus, the middle angle is 90, they told me this part is 8, so this piece I highlighted is also 8. We're missing the other piece, so I'm going to call it x. Two sides of a right triangle, I need the third, so I'm going to do Pythagorean theorem. So you can pause the video to find it, but if you find that, you will get x to be 15. So that means this part is 15, and up here is 15, and then in my formula, I do area is 1/2 diagonal 1, which is 15 plus 15, 30, and then the diagonal 2, which is 8 plus 8, which is 16. And then I get 15 times 16, because a half of 30 is 15, and then 15 times 16 gives me an area of 240. So that's a review from last unit. Then we have a kite. So if you look at this kite, what shape is half the kite? So here's my kite and they showed half, and that shape is a triangle. So if you don't want to memorize the formula, what you could do, like if I wanted the area, if I draw the other half of the kite in, what I could do is I could find the area of the triangle and multiply it by 2. So this 4 would be my height because it makes a right angle. And then that height is perpendicular to this length, which is 10. So the triangle's area would be 1/2 4 times 10, which will be 20. And then the kite's area would be 2 times that, which is 40. The other way is you can memorize the formula. So what we realize is that this length is D1, and if I call the other length like this 10, D2, the kite for a formula is the same, the area formula for a kite is the same as a rhombus. So it's 1/2 diagonal 1 times diagonal 2. So that would be our formula. The reason is, like, if we do this, if we did the triangle, it would be 1/2, and then you have half the diagonal times the diagonal 2. And then you'd have to multiply it by 2, so that would give you the entire diagonal, and so then you have 1/2 diagonal 1 times diagonal 2. So then we're going to find the area of this kite using that formula. So we have 1/2 diagonal 1 times diagonal 2. So we're going to look at this, and they gave me 12, the 15, and the 41. So I'm going to have to use those to find my other diagonals. So again, we have a right triangle, and I'm going to call this x, and we can use Pythagorean theorem. Okay, so you're going to solve that. So you can pause the video to solve it. And if you do that, you're going to get x to be 9. And then from last unit, this part and this part of a kite are equal, so that's 9. So now I have one of the diagonals, which is 18, but I'm still missing this piece here, which I'm going to call y for now. So again, we have a right triangle. This is 9, that's y, this is 41. So to find that, I would do a squared plus b squared equals c squared. And then if you solve that, you should get y to be 40. So then this diagonal, the other diagonal, is 12 plus 40, because I add the two pieces, which is 52. And then my area is going to be, if I multiply that out, 468. Now again, we could have just done the area of a triangle, which is 1/2 9 times 40 plus 12, which is 52, and then multiply it by 2, and you'd get the same answer. The next thing we're going to do is area of the shaded regions. So it's going to either have more than one shape, or it's going to be one part is shaded and one is not. So in order to do that, we have to figure out either what two shapes they are and then add them if we're combining two areas, or if one part is not shaded, then we'll subtract to take away. So this, we have a triangle and a half circle. So we're going to find the area of both parts and add them. So I'm going to draw again the height for the triangle, which has to make a right angle, so that would be here, because it's the only place to draw it. And so that would cut this piece in half, so this would be 4. And we have to find the height, so again we use Pythagorean theorem. And if you solve this, your height is 3. And so for my triangle, the area would be 1/2 the base, which is the entire thing of 8, times the height, which we found to be 3. And then I would add an area of half a circle. So a circle's formula is pi r squared, and we're actually doing a semicircle. So we take pi r squared and we divide it by 2. So I'm going to do pi. My radius is this distance from the center to the circle, so that's 4 squared, and then I'm going to divide by 2. So if I multiply this out, I get a half of 8, which is 4. 4 times 3 is 12, and then 4 squared is 16. 16 divided by 2 is 8. So I have 12 plus 8 pi. If they ask you to leave it in terms of pi, you leave it like that. If not, then you're going to multiply that out. And if you multiply that out, you would do 12 plus 8 times pi in your calculator, and you should get 37.1. For the second shape now, we have an outer circle and an inner circle, and I want just the shaded region. So I'm going to take the area of the entire circle and subtract the area of the unshaded, and that will give me like the tire, that part. So we need the entire radius, which has a 2, and then this is 6, because that's the radius there. So the whole radius is 8. So we have 2 circles. So I'm going to do pi, the entire radius, which is 8 squared, minus, and then pi, the inner circle, which the radius is 6 squared. And so 8 squared gives me 64 pi minus, and then 6 squared is 36 pi. And if I want to keep it in terms of pi, I just subtract 64 minus 36, and I get 28 pi. I can do that since both of these have a pi and they're like terms. And if I want to multiply that out to the nearest tenth, it's 31.3. And here's a few more examples. So we want to find the area of this shaded region of this rectangle. So what I can do is I can take the base and multiply it by the height of each part, and that will give me the area. So we have to figure out what is the height of all these pieces. So they gave me the height of the unshaded region, which is 5, 7, and 5. So I'm going to get the height of the shaded region, I'm going to take 30 and subtract 5, 7, and 5. And then my height for all the shaded regions is 13. And then to find the area of the shaded region, like if I put those all together, I could just do 15 times 13, which is 195. So the area of the shaded region is 195. This one, we want to find the area of the shaded region, 2 congruent circles. So we have a rectangle, and then we want to take away the 2 circles. So I need to do the area of the rectangle minus 2 times the area of one of the circles, because they said that the circles are congruent. So to find the rectangle, I'm going to draw the 2 diameters. This has to be 5 since it's a radius, and then this would be 10 because 5 plus 5 is 10. So the width or the length of the rectangle is 10. The height, if I draw my radius, again my radius is 5 and my other radius is 5. So the height is 10, so I would do, back here this is 20. Because I do 10 plus 5 plus 5, so that's 20. So then my area is base times height, so 20 times 10. And then I'm going to subtract the area of a circle, which is going to be 2 times 1/2. 2 times, not 1/2, 2 times the area of one circle, which is going to be pi 5 squared. And then we would multiply that out to get an answer, and if you do that, you would get 200 minus 50 pi, and that is equal to 42.92. And then this example, we want the shaded region. So this is kind of a combination of both types. We have a rectangle with a square taken out of it, and then we have a triangle. So we're going to have to find the area of the big rectangle and then subtract the square, and then we will have to add the area of the triangle. So the rectangle is base times height, which is 8 times 12. A square is the side squared, or base times height, so that's 5 times 5, or 5 squared. And then the triangle is a little bit harder. They didn't tell me the height. So we know this distance is the length of the rectangle, which is 8, and it's cut in half, so that's 4 and 4. And this would be a right angle, because our height must make a right angle. So to find the height, again, we would do Pythagorean theorem. This is one we've done multiple times. So h is 3. And then we would do 1/2 the base, which is the entire base of 8, times the height, which is 3. And then we multiply it all out. And if you add that all together, you should get the total area to be 83. And then for the last one on this page, we want this shaded region. It's called a sector. So what we're going to do is we're going to find the area of this whole region, which is our sector, and we're going to subtract the triangle, and that gives me the shaded region, which is called a segment, actually. So for the area of a sector, if you remember, is the angle, the central angle over 360 times pi r squared. And then we're going to subtract the area of a triangle, which is 1/2 base times height. So to find the area, we do 90 over 360 times pi, and then my radius is 8 squared. This is my radius. So we get 16 pi, and then we're going to subtract the triangle. This is both 8 because they're both radii, which is 1/2 8 times 8. So we're going to subtract 32. And then again, you have to plug that in your calculator if you want to get it as a decimal, and you should get 18.3. The other way to find the area of the sector, which we did somewhat, is you can set up a proportion. So you could have done the angle over 360 is equal to the sector area over the total area, which is pi r squared. So if you were due to this, we did 90 over 360 is equal to the sector area, which we're trying to find, over pi, and then 8 squared. And then if you cross multiply, you solve for it. So if you cross multiply, you get 5,760 is equal to 360x. And you divide by 360, and you get x to be 16 pi. And there should be a pi here. I lost that. So that's the other way to find the area of the sector, and then you would do the same thing, subtract the area of the triangle. So the last two problems are last four problems. We're working backwards. We have the area of a triangle is 24. The height is 8. Find the base. So they said triangle. So I'm going to write the formula, which is 1/2 base times height. I know the area, so I'm going to plug that in. 1/2. I'm trying to find the base, so I'm going to leave that as the base, and 8 is 8. H is 8. And then I'm going to multiply the 1/2 times the 8, because the order I multiply numbers doesn't matter. So I get 1/2 of 8, which is 4. And then to solve this, you divide by 4, and we get 6 inches. The next one says the area of a square is 81 centimeters squared. Find the perimeter. So if you think about a square, all the sides are equal. And so the perimeter, we would add all the sides, which means the perimeter would be 4 times s. So we need to figure out the side length. So we're going to use the area formula, which is s squared for a square. And I'm going to have 81 is equal to s squared. So we take the square root and we get 9. And then to find the perimeter, we would just do 9 times 4, which is 36. And if we're talking about perimeter, the units are also just centimeters. So the last two, the area of a trapezoid is 108 centimeters squared. Two bases are 8 and 10. Find the height. So again, I'm going to write the formula. So it's 1/2 h b1 plus b2. You have to find that on your formula sheet. I'm going to plug in the area. The height I'm trying to find, so I leave that as h, and then I plug in my two bases, 8 and 10. The order does not matter. So then I'm going to do parentheses. 8 plus 10 is 18. Multiply the 18 and 1/2 because it doesn't matter what order we multiply. And then to solve it, we would do 108 divided by 9 for our height. And we get a height of 12. And the height would be centimeters. And then the last one, again, area of a trapezoid is 150. So I'm going to write the area formula for a trapezoid. The height is 20. One of the bases is 10. Find the other base. So I have 150, 1/2. I'm going to plug in my height, which is 20. One of my bases is 10, and then I'm just going to call the other base b. So I have 150. I'm going to do 1/2 of 20, which is 10, and then I still have parentheses of 10 plus b. So then we have to distribute. So I get 150 is equal to 100 plus 10b, and now we just solve it. So we subtract 100 and get 50, and then divide by 10, so b is 5. And you can always check it by plugging into the formula. So I would do 1/2, the height is 20, and I'd add my 10 and 5, and you're correct if we get 150. So the work backward ones are nice because you can always check if you got the right answer. And I checked it and I did get 150. You could also do the same above. So that is our lesson on 11A.